In this video, I want to spend some time talking about the entities that we have in our database, and in particular, I want to focus on entries. So for the purposes of this application, an entry is an entity that has a start and an end time and a command. And what's important about it is that an entry is always associated with a specific job. So if we were to use a relational database to model this relationship, we would say that a job can have 0 to n entries, and an entry always has one and not more than one job. And if we wanted to represent this relationship in Firestore in terms of documents and collections, how would we do it? Well, one possible approach would be to create a new sub-collection called entries inside each job, like this. And this collection would contain a document for each entry inside the parent job. And if we go for this approach, then listing all the entries for a given job becomes easy, because we just need to get the path to the entries collection for that job and return all the contents at that path. And creating, editing, and deleting entries is easy as well, because we just need to point to the correct location in Firestore and perform the appropriate operations. So if we wanted, we could try to add some new API paths so that we can store entries as a collection inside each job. However, when we consider the last requirement about viewing a breakdown of all jobs with the total hours and pay, then we would have a problem, because in order to represent this, we would have to get all the entries. And this means executing a query for each job to get its entries and combining them together. In other words, if we represent entries as sub-collections inside jobs, then a few requirements become easy to implement, but there is one additional requirement that becomes hard and inefficient to satisfy, as we would have to run multiple queries. So a better schema that satisfies all the requirements but doesn't get us into trouble is to go back to our users collection, and then we can create just a single entries collection like this inside each user. And then we can store all the entries as documents inside this collection. And since an entry is always associated to a single job, we also need to add the job ID as a field to each entry. In other words, we want to modify our API path to specify the entries with these paths instead. And as you can see, the job ID is no longer part of the path, but instead it can become a field inside the entry documents. And with this structure, getting all the entries for a given job becomes a case of getting all the entries for the user and only selecting the ones that match the job ID. So going forward, we are going to use these new API paths. By the way, when designing the time tracker app, I was able to list all the requirements and database queries in advance. However, we don't always know everything up front when we build new apps. And this means that it's easy to organize collections and documents in a certain way when starting out, but when new requirements are introduced, then the initial structure may not work so well. And if your database is already deployed in production and you have to introduce a breaking change to accommodate new requirements, then you are going to have a hard time with it. So in summary, there is one message that I'd like to get across here, and that is that NoSQL or non-relational databases like Firestore may work well for specific cases. However, when working with data that is relational in nature, you can encounter problems when new requirements and queries are introduced. And my advice here would be to keep this in mind before you choose a database for your project. And while Firestore is easy to use and has many advantages, it might not be the right database in some cases. Okay, so let's continue on the next video.